Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. On. In this tutorial video, we'll go through some alcohols chemistry. This is for the AQA topical series, which is suitable for any 16 to 18 years old pure chemistry, advanced chemistry students all around the world. In this first question, so this is alcohol A. If I convert this into skeletal formula, because skeletal formula is the best and the most elegant way and the fastest way to go through any organic question. So we have a CH3 twice, so CH3 twice. We're looking at the CH now, CH, and there is a CH, and there is a OH, and there is a CH3. So let's follow this again. Looking at the formula, CH3 twice, two of them. CH because carbon form 4 covalent bond, 1, 2, 3 are shown there. You don't show the hydrogen bonded to the carbon in skeletal formula. And then this is bonded to CH, again carbon form 4 covalent bond, 1, 2, 3. There is a hydrogen there. And then this is your OH and this is your CH3. So if we look at priority group, I could go 1, 2, 3, 4 for the longest chain carbon in pink. But I could also go from right to left, 1, 2, 3, 4 in black there. So in terms of my branches, if I go pink, the OH is the more important group than alkanes. Alkane is not technically a functional group, so OH is a functional group there. It's hydroxyl functional group. We want the lowest number for the high priority group. 2 is smaller than 3, so I will go for 2. So this is an alcohol. It's 4 carbons, so this is called bute. So this is butane 2-ol, but I have a branch. My branch is at position 3 as a result of putting in the alcohol as the high priority group. So now I got 3 methyl because it's 1 carbon chain there, 1 carbon branch chain there. So 3 methyl, butane 2-ol there is the correct IUPAC name there. Now draw the structure of the organic product when you oxidize it using acidified potassium dichromate 6. So this 6 there is the oxidation number of chromium. So this is saying that chromium is plus 6. This is the shorthand notation for writing in the oxidation number of chromium is plus 6. The plus is essential for oxidation number as you need to specify the charge and not just the value unless it's 0 there. So acidified is required as a reactant. Without acid, it's not going to react. H plus, K2Cr2O7. If we look at the oxidation number of the whole compound, K2Cr2O7 is a compound with no charge. So overall is 0 oxidation number. You have 2 potassium. Each potassium in a compound is potassium ion, so it carries a charge of plus 1. And that is why the oxidation number from the 2 potassium ions is going to be 2 times plus 1. I have 2 chromium. My objective is to find the oxidation number for each chromium because oxidation number belongs to one particular atom and not 2 atoms. I have oxygen in the compound, so that is oxygen having a charge of -2 or oxygen having oxidation number of -2. But I've got 7, so 7 times -2 plus the 2 chromium plus the 2 potassium ions overall give me 0 oxidation number because the compound itself has no overall charge. So what now? I will have 2 chromium equal to 0 minus 2 plus 14, chromium equal to plus 12 over 2, and that is how I get chromium plus 6 there. In terms of coloration, this is going to go from orange to green. So the green coloration there is due to chromium 3 plus, which is chromium plus 3, whereas the orange coloration there is chromium plus 6 due to the dichromate 6 oxidation number there. Very, very important color change here. In terms of the oxidation of alcohol, we look at this alcohol, the carbon with the OH, the carbon with the OH, if I circle this in pink, the carbon with the OH is bonded to 1 and 2 other carbons. This is what you call a secondary alcohol. A secondary alcohol only has 1 hydrogen on this carbon with the OH, so you can only lose it once, and what's going to happen then is it's going to give you a ketone. They said draw the structure. They did not mention skeletal. They did not mention structural. They did not mention display. So you could get away with drawing skeletal, which I did. I could get away with drawing structural if I want to. So everything else is the same, but the CH-OH, the CH and OH lost the hydrogen. Losing the hydrogen atoms is what you call oxidation, which you could obtain, which you could achieve with this acidified potassium dichromate 6 as an oxidizing agent. Oxidizing agent oxidizes other substances. Itself get reduced. Itself decrease in oxidation number. but the alcohol get oxidized and you will lose the one hydrogen and it become ketone, where you still have the CH3 group on the other side. So this is CH3 twice CHC, double bond O, and then CH3. So you could draw either of these product and it will be fine. You shouldn't draw both of them, but the first one on top there is skeletal formula, where you only show the bare skeleton. The one at the bottom there is called structural formula. So you learn structural formula from IGCSE or O-level chemistry, but you have learned skeletal formula from AS chemistry. So that one, both of them are fine. If you draw display, it's also fine, but I don't want to waste my time drawing display here. If you have so much time in exam, by all means, it's 1 mark. It's probably lesser than 1 minute. In part C, we get two isomeric alkenes when you dehydrate A. So the dehydration of A, this is basically what you call the elimination of water. So you're going to kick out water molecules, so there's elimination of H2O. Very, very particular. You can use corn sulfuric acid, and also you heat it up to like 300 degrees Celsius to get rid of the H2O there. So name the mechanism. The mechanism is going to be elimination. The type of reaction is also elimination, to be honest. So if I draw A again, which was the correct skeletal formula, so it was going to be like this, OH and then the methyl group. We are doing elimination, so we need to look at this is the carbon with the OH, which I'm highlighting in pink. We cannot get the hydrogen from there. We have to get the hydrogen from the adjacent carbon. So I could draw the one in black here. So this is one possibility. This is a CH3. This is a CH. So there are two distinct possibility here. So that is going to be a distinct possibility. I think that ink is not very nice. Let me use something else which is totally different. Hopefully this color will contrast it much better. So this red color one is on a CH. There is only one hydrogen there, but there is 3 of these black hydrogen on the other side. If I do the elimination from the red color one, my double bond will be there. So what I'll get is I will get my double bond there, and I'll still have a CH3 on the other side. If I do the black color one, my double bond will be there. So I will get a single, but I'll get my double there. So you could have them the other way around, doesn't matter, but essentially you must draw the structure, which again they did not specify structural or skeletal or display, so you could draw any of them. I've just chosen to draw skeletal. If I convert this to structural, it will be CH3 twice and then C double bond CH3. Because this is CH3 twice, there is a carbon with no hydrogens, since carbon form 4 covalent bond, and there is a hydrogen there, 1, 2, 3, so there must be 1 hydrogen, and there's a CH3 there. On the other hand, I have a CH3 twice CH, because there is a hydrogen here, because it is single, 3 covalent bond, so 1 more hydrogen, and then onto the other one is also a CH, and then a double bond, and then a CH2. Could be the other way around, doesn't matter, but essentially I'm just reading off the skeletal formula for the structural formula. They didn't ask for structural or skeletal display. You can get away with drawing any of them. Now, what type of structural isomerism are shown by C and D? The positions are changing, because if you look at the naming, this will be 1, 2, 3, 4, because if I go the other way, in blue, let's say 1, 2, 3, 4, my methyl group at carbon 2, my methyl group at carbon 3, you want the lowest number possible, so you go for the blue color, for the black color one actually. And now you want the lowest number possible for the alkene as well, so not just for the branch, for the alkene as well. And that means we're looking at 1 int, so this is 1 int, and this is 3 methyl, because the int will take priority over the methyl group. Just like just now, I should have gone through the alkene functional group, which 2 is lower than 3. So therefore, this is build 1 int, this is build 2 int. Of course, I haven't factored in the branch yet. So name the type of structural isomerism. They already told you that it's specifically structural isomerism, which there are 3 types, because there is chain, but there are 4 carbons in the straight chain for both of them, so it cannot be chain. Functional group, we know that alkenes and cycloalkane are functional group isomers, but there is no cycloalkane. Both of them are normal generic alkenes here. So the last one is called position, and that is what we are seeing here. Build 1 in, build 2 in there. Now list alcohol A, product B, and isomer C. What is this? Alcohol A. alcohol A is going to be like this just now, I think. Yep, there was A. And then what else? We have B. And what was B again? B was the ketone. So B was the oxidized product, is the ketone. And then C was this alkene isomer. So it doesn't matter this or this. So this is just alkene. And B is ketone in order of increasing boiling point. So this one will be the highest because of its ability to form hydrogen bonds. You have a hydrogen bonded to highly electronegative atoms, oxygen, fluorine, and nitrogen, and you have lone pair on the oxygen. This one, only permanent dipole because there is no ability to form hydrogen bonds. The oxygen is not bonded to hydrogen. But here, only London dispersion forces, or you can say only weak van der Waals forces, so no permanent dipoles or whatnot, because there is no polar or electronegative, very electronegative atoms like oxygen in these alkenes here. So the lowest is going to be C, and then it's lower than B and lower than A, which can form hydrogen bond there. Part G, draw the structure of the isomer of A. So isomer of A was, what do we look for in A? We have 1, 2, 3, 4, 5. It's a 5 carbon alcohol. Because there are 5 carbon altogether. 1, 2, 3, 4. And then the 5 carbon and then an OH. So we know it's a CnH2n plus 1 OH. Not oxidized. That's the key concept there. So that means we are looking at tertiary alcohol where there is no hydrogen on the carbon with the OH because it's bonded to 3 other carbon. If it is bonded to 3 other carbons, therefore there is no hydrogen on that carbon with the OH. So if I draw my skeletal formula, I would draw my OH. 1, I have 1, 2 already. 3, 4. So there's 1, 2, 3, and 4. I already got my tertiary alcohol, but be careful, I want 5 carbon alcohol. 1, 2, 3, 4. So I could just add 1 more 5. And that is a possible structural isomer of A. In fact, I think that's the only possibility because, you have a central carbon, bonded to 3 other carbons, then you could add the extra carbon there, or there, which doesn't matter because they can rotate around by symmetry. So this is the only structure. If you want to give this a structural formula, find the longest chain carbon. This is going to be 3 carbons and not 2 carbons for the longest chain. This is going to be, if we look at the main chain, CH3 at carbon 3, CH2 at carbon 2, C, and then CH2, CH3, and then OH. So this is part of the main chain. These are like the branch on that position 1 there. So that is structural. They say draw the structure. They don't say draw skeletal. They don't say draw skeletal or structural formula. Both of them will be equally acceptable as long as you are correct there. Last but not least, draw the structure of isomer of A. So isomer of A again is the alcohol. And we are looking at cannot be dehydrated. You cannot be dehydrated if you have no hydrogen on the adjacent carbon. We are looking at the carbon adjacent to the carbon with OH. So if I start off with drawing like this, let's say, I think that will not work because this is 1, 2, 3, 4, because then if I add it there is hydrogen there, so it doesn't work that way. So let me just put in the OH first. So we don't want any hydrogen here, so no hydrogen there. We have 5 carbon alcohol to play with, 5 carbon alcohol. So I can put 1, 2, 3. 1, 2, 3, 4, 5 carbon alcohol. So if there is no hydrogen there, this is the only adjacent carbon because this is on the other end. There is no adjacent carbon here. This is the only adjacent carbon next to the carbon with the OH. There is no hydrogen there. They say draw the structure. They don't say a structure because there is only one possibility there. If you think about it, I think this one is going to be CH3, C, CH3, CH3, CH2, OH there. Again, At the bottom there is structural. Structural is difficult to see unless you have drawn the skeletal. So if a question asks for structural, I will still draw skeletal first and then convert to the structural correctly. You don't need to draw both because they don't ask for both. They don't ask for either. You can draw either and you'll be fine for that 9 marks question overall. And I'll just leave it there for these short tutorials on alcohol chemistry. Hopefully that has been useful. Don't forget to get in touch at country code +673 and the number is 8656158 for private tutoring where you can go through any concepts or any question of your choice. And yeah, do follow me at ptet.chemistry. That's at ptet.chemistry. On Instagram, Facebook, Twitter, and Telegram to get connected. Do click the button on the bottom right to subscribe to my channel and follow my work and do subscribe to the channel and upgrade to full paper tutorials as well for more great resources. Thank you for watching. I'll see you in the next tutorial video.